sense. So on your simplification, it depends with how the questions are given. Sometimes you might have questions under addition, you might have questions under multiplication and division. The whole idea is from normal fractions. Besides using the use of a calculator, what we actually know is that if you are adding or subtracting two fractions, let's say we have got two fractions that we are adding or subtracting, for example, 3/7 minus 1/6, or maybe we've got 3/7 plus 1/6. The actual part that was supposed to be made was to find the LCM of given denominators, which is 7 and 6. We are supposed to find the LCM, which is the one that you are going to divide to say LCM divided to this number. Whatever that you get, you're supposed to multiply it to the numerator. The same thing, LCM divided to this number. Whatever that you get must be multiplied to -1. Then you can simplify further, maintaining the LCM, meaning to say whatever that you're going to simplify, the LCM is supposed to be there. This is the same approach that we are simply having, but now we are no longer dealing with numbers. We are dealing with algebraic expressions. Now we have got expressions under algebra, which needs to be factorized before simplifying, like this one. It's an addition, which can be under subtraction again. So the same concept that I'm going to explain under addition is the same concept under subtraction. So we're just going to use this one as our example, where we are given to simplify this whole expression. All right. So what you need is to analyze before you attempt your question. It's under addition, where you're supposed to find the LCM, which is true. We are supposed to find the LCM of these given denominators. But checking our denominators, you can see here, it's something that is not factorized. We've got a difference of 2 squares there, quadratic expression. And also, if you check the order, we are starting with A followed by B here, A followed by B here. But if you check this part, it's not exactly what we have from the others. Here it's B minus A. So which means we have to write this part in terms of the others, like the way we are given other terms, in terms of A plus B and so on. All right, so these are the things that you're supposed to consider while it's simplifying. So here, let us start with the first one. 2AB, there's nothing that we can do here. So you can just rewrite as it is. We can't factorize anything here on this one. Then what about A squared minus B squared? This is our basic introduction of a difference of 2 squares. We know that A squared minus B squared is supposed to give us what? Supposed to give us 2 brackets, or A minus B into what? Into A plus B. So that is our basic approach of what difference of 2 squares. Then we have got this part that I was explaining of B minus A. Since we can see the terms, we are starting with A. So we are supposed to do the same thing on this one. So meaning to say this whole part here could have been written as A over, there's a plus that we are having here. So that's why we're just writing as A there. Then if we are to start here in terms of A, it was supposed to be minus A plus B. We just rewrite. The A is carrying a negative, the B is carrying a positive. But it does not make sense for us to maintain the first term carrying a negative. That is why they had to rearrange like this. So now as we want to make this A to be a positive, just like all of these A's that we see, they are positive. So what are we going to do to make this a positive? We are supposed to factor out this negative, which is on A. The moment we factor out this negative, it means negative A divided to negative. We are now having a positive A. Positive B divided to a negative, the one that we factored out, it's now a negative B. So meaning to say we are now having this with what? With a positive A. But considering the sign that we had before, it was a positive. Now we've got a negative outside. So positive and a negative will give us what? Will remain, will give us a negative there. So meaning to say this sign is going to be affected by the sign that is outside of the bracket here. So meaning to say if here there was a minus, it was going to be minus, minus, which gives us what? Which gives us a plus. So that is what we have to consider. So now we have a negative and this part remains as it is. Now we are going to take this part. That is, we are going to take what? A over A minus B. So we now have this as A over A minus B in the same sense of other, starting with what? Starting with a positive term and the term being A. That is what we want. The term must be A, like other terms. All right, the next term, is there anything that we can do here?
There's nothing we can do.
So there's nothing that we can do there. We just have to rewrite as it is. So this is going to be plus A over A plus B. All right. Then here we've got a plus 1. Is there anything that we can do on plus 1?
Nothing can do.
All right. So here we can leave it like that, or we can write this 1 simply. If we've got 2 over 2, what do you obtain? You obtain 1.
1.
If you have got 10 over 10, you also obtain 1. So meaning to say the other way of writing this 1 was to take from the common of everything, the one that carries all the terms, which is this one of A minus B into A plus B. So meaning to say in place of 1, we could have written it as A minus B into A plus B, everything over A minus B into A plus B, which is one and the same thing that you are still going to obtain even if you use it as a 1. So this was going to be 1 over 1 as a fraction, just like others we put fractions there. So now we can be able to find the LCM. So we need to find the LCM of everything that we are given here. And remembering from our mathematics N2 that LCM, each and every bracket, each and every term that is present must be taken. Each and every part that we see must be taken. But we do not repeat the terms if they appear twice. Like we've got A minus B, we've got A minus B. So it means it has to be taken on our answer. We are not supposed to repeat this one. We have got A plus B. We've got A plus B. We just take it once. We do not repeat this. We have got a 1. So having or writing a 1 does not even affect anything. So we can just leave our LCM as what? A minus B into A plus B. So from there, what are we going to do? That's where I was explaining. So if there were numbers, we divide. It's the same thing with terms, expressions. You are going to divide your LCM, this one, to each and every denominator that you have. So it's a division that is actually happening. You are dividing the LCM to each and every term that we have on our denominators. Like this LCM, it's A minus B into A plus B. You divide to the first denominator. Our first denominator is this one. What do we have there? We have got A minus B into A plus B. This is the actual sense of what is happening. So as you can see, we cancel, we get a 1. So even by sight, you can even see that, okay, these two, they are the same. So they will just cancel each other. We remain with what? We remain with the 1. So the 1 that we are remaining with will multiply the numerator. So it's going to be 2AB times 1 or 1 times 2AB, whatever way that you want, or it can be 2AB into 1. We multiply that to the numerator. All right, there we've got a minus and A there. So we are going to multiply whatever that we are going to get to minus A. So we divide again our LCM. This is our LCM to the denominator of A minus B. If we are to divide, what is going to happen? Let's say we have divided by just side by side. We can see that A minus B here and A minus B will cancel. So meaning to say we are going to remain with what? We are going to remain A plus B. But if you don't understand, write your terms, your LCM is A minus B into a plus b like this, you divide to a minus b, this one. You write your a minus b like this. You can see, okay, this and this cancels. A plus b is remaining. So this is the case that we have. Okay, here there's a plus, so there's plus a. So you're going to have plus a times whatever that you're going to get after dividing this part. All right, so if we divide a minus b and a plus b into the denominator, which is a plus b, what's going to happen? This a plus b and a plus b will cancel. But as we are not canceling, we just see, okay, this one and this one cancel. We are going to remain with what? We are going to remain with a minus b. So the part that you remain with is the one that you write on top, but don't cancel anything. All right, plus we have got a 1 here in the numerator, so it's going to be 1 times whatever that you're going to get. So if we divide our LCM here to 1, what are we going to obtain? It's just going to remain as it is, and if you divide by 1, so it's going to remain as it is, a minus b into a plus b. It's like you are dividing 2, divide by 1, it just remains as 2. So this divided by 1 remains as it is also. So this is where we are now. What do you think we're going to do now at this stage? We have to simplify everything. But to us to simplify, we need to expand the brackets, and the brackets that you expand are the ones for the numerator. In this case, you expand the brackets that is from the numerator, knowing that what expands the bracket is the number that is affecting the bracket. Like here, we've got a 1, so this 1 is going to multiply 1 times 2ab, which is 2ab. We move on to this term. What is affecting this bracket is this term as it is, minus a. So meaning to say, we're going to have what? Minus a squared. Then we've got minus a and b, which is going to give us
ab, negative a, b.
Negative ab. We are done with this part. We move on to this part. What is affecting? Plus a. So plus a times a, which is going to be plus a squared, plus a times minus b, which is going to be what?
Minus ab.
Minus ab. We are done with this part. We move on to this one. What is affecting? Here it's 1, but here there are 2 brackets that we see here. 2 brackets. So what is going to happen? We have to expand these brackets, but by just mere looking these brackets, a minus b into a plus b, where are these brackets taken from? They are being taken from what? The difference of 2 squares of a squared minus b squared.
Okay.
But in case that you have not realized that it's from difference of 2 squares, therefore expand your brackets. A minus b into a plus b, you expand your brackets. A, we have a squared, a and b, we have ab, minus b and a, minus ab, minus b, and this one we get minus b squared. This part cancels, meaning to say you remain with a squared minus what? A squared minus b squared, which is the same thing as what we have here. But this part of a squared minus b squared, it must be multiplied by what? By the positive 1. So if we multiply by a positive 1, is it going to affect? It's not going to affect. Plus 1 times a squared, that would be just plus a squared. Plus 1 times minus b squared, minus b squared. Everything over the LCM, maintaining our LCM as it is, which is a minus b into a plus b. So what we need now is to simplify, collect like terms. So we have got the part with ab. This is 2ab. Here there is minus 1ab, minus 1ab. So it's 2 minus 1 minus 1. So this one will cancel, and 2 minus 2, which is a 0. So this one cancels there. All right, we simplify. Here we've got minus a squared plus a squared. So this is minus 1 plus 1. So this one cancels again. So what are we going to remain with at the end? If you have to check here, we are going to remain on the top. Is there anything that can cancel? These 2 cannot cancel. These are unlike terms. So we are going to remain with a squared minus b squared. Everything over what? over the two brackets, A minus B into A plus B.
Plus B, yeah.
But can we leave our answer at this stage?
No.
We are supposed to factorize again because that A squared minus B squared can be factorized, our difference of two squares again. So meaning to say we are back to the two brackets of A minus B into A plus B. So we are going to have our difference of two squares brackets over A minus B into A plus B, the one that we had previously. So if we had to check this, can cancel, meaning to say we remain with 1 over 1, and 1 over 1 gives us what? 1 over 1 is same as what? Is same as 1. So
Yes.
that is what will be required. Mostly, this is how your questions are going to be like. This is how your questions will be like on addition. You have to be very careful. First, analyze the first part, this one, the first part, how it is given. As you can see, it now, our question now changed. It was now having a subtraction there because of our terms. So you have to check the order. Are we given x plus y, then the other part they give us y minus x. You check what is common in terms. Here you can see that this part is starting with A, this one is, so it does not make sense for us to change the other part that we have. So the only part that is being that is affecting us is the B minus A. So that is the one that we have to change so that it looks the same way as the other terms or other expressions, the way they are given. So after that, the simplification part, it's taken back again from our N2, as it was only that we are now just having more terms or more brackets or more simplification that might happen, but the idea there of adding, subtracting is one and the same. We are simply referring to one and the same. All right, so this one I'll just try after this class to just combine some of the questions so that I will just send you on addition and subtraction and even others so that you see, but the idea there is the same. We have a multiplication part again that we might have. So the multiplication is simply taken again from our ordinary multiplication that we know. Is we are given, let's say, 2 over 7 times 7 over 8 like this. Now, because of the use of calculators, these techniques are now very, very difficult for you guys to see this, but these were not supposed to be difficult if we had not abused our calculators that much. We know that from our simplification of a normal fraction like this, what you do is that you simply cancel the relationship between the numerator to the denominator, like 7 and 7. We can check between 2 and 8. Is there anything common? 2 into 2 here, 1, 2 into here. We've got a 4. This is the actual way that we're supposed to do. Then you multiply, we have got a 1, a 1. The relationship that we have between the numerators is that they can only be multiplied together. So we can multiply 1 times 1, which is 1 over. The same thing, denominators, their relationship is they can be multiplied only. That is what we have between the denominators. So you can multiply 1 times 4, which is a 4. But as long it is from numerator denominator, it has to be divided. But along the denominators only, it's multiplication. Along the numerators only, it's multiplication. The same thing under division also, we understand if we are given 3 over 7 divided maybe to 3 over 4 like this. That was supposed to be the normal way. We can't divide fractions direct. So what we do is that we have to introduce the multiplication where there is a division. That same idea is the one that we use even in our algebra. So the moment we introduce a multiplication here, what happens? The second fraction, we have to invert. We have to interchange the numbers there. So it will be 4 over 3. The moment you have 4 over 3, we are now back to multiplication. So as you can see, wherever there's a division, the question goes back to the normal multiplication. Once you're under multiplication, what is the relationship? Numerator to the denominator, I can cancel. But numerator to the numerator, I can only multiply 1 times 4, which is 4, 7 times 1, which is 7. So this is the idea that we are supposed to bring from our normal fractions, but now we are working with algebraic fractions where you ask to use this concept, but there is a factorization, there is a lot that we need to consider there, but idea being the same. Like if you are to check here, we are given the first part and we've got a division here. So meaning to say, for us to simplify this part here, we are supposed to introduce multiplication. Forget about the factorization. We want to first clarify our fractions so that we'll talk about the factorization later on. So it's easier before you forget that. So introduce what? Introduce multiplication here. So that means we're going to have x squared plus x minus 2 over 6 minus x. Yeah, I'm not changing anything. I just want to introduce a multiplication here. The moment I introduce multiplication, what happens? I have to interchange this fraction. So meaning to say we now have x squared minus 3x plus 2 on top over what? Over x plus 2. Multiplied here, is there anything that we need to change? There's nothing because it's already under what? It's already under multiplication. So this part we are just going to take as it is, times x squared minus 2x plus 1. After you have multiplied, after you have everything under multiplication like this, that's where now you can think of your factors, because you know that under multiplication, we can cancel whatever that we want. As long it is from the numerator to the what? To the denominator and is common, we can what? We can cancel. So that is the first thing before you forget that. But at this stage, simplify, do your factorization, apply your factorization techniques there. Factorize your terms, and also considering that part that I said, if terms like this, you can see we are starting with x, x. So it means all terms, they must start with an x. But if you check here, this term here is not starting with the term. So you have to interchange so that it starts with what? With x. These are things that you need to analyze whenever you are given your question to check for this. All right. So let's start with the first one. X squared plus 2x minus 2, this one. What can we do? We can, this one we can simply factorize, and the coefficient there of x squared is 1. So I said here, you simply need 2 brackets that you're going to consider. We've got x and x. Then what are the factors of what? We consider the constant. So we need factors of minus 2, what that will add up to 1. Do we have factors of negative 2? Factors of negative 2, which you add up to 1.
1 and negative 2.
All right. If we use 1 and negative 2, is it going to add up to 1? Because we are saying if we are to add them now, these factors, they must add up to 1. So can we just correct them? It must be 2 and what? It must be 2 and negative 1. So that if you add 2 plus minus 1, you get what? You get positive 1.
Yeah.
So meaning to say the numbers that we want here is 2 and minus 1. So these are the numbers that we're going to take, plus 2 here, minus 1 there. All right, then we move on to this one that I was saying. As you can see here, we are not starting with x. Our term is starting with another term, which is 6. So what are you going to do? We have got 6 minus 3x. We have to start by writing x. So meaning to say the term that is carrying x is what? It's negative. So it's going to be negative 3x. And 6, it's a positive. There's no part that is changing. So we're just rearrange, starting with the first term being x. But after doing this now, we have to factorize. And by factorizing, we must make sure that x remains a positive. X must remain a positive. So what are we supposed to factor out so that x becomes a positive here?
We must factor out minus 3.
We are going to factor out negative Negative 3.
3.
So that if we divide negative 3x divided to negative 3, negative cancels, it will be a positive.
Positive, yes.
Then it's plus 6 divided by negative 3. A plus and a negative, it will give us a negative.
Negative 2.
So meaning
Negative
to say,
2.
we have our x being positive. Our major part is the x must be positive. What goes here or whatever, we don't care about it. Our x is supposed to be positive there. So meaning to say, we are going to have this as what? As negative 3 into x minus 2. All right, let's move on to another one. What about this one? What are you going to do? X squared minus 3x plus 2 is the same as the first one. The coefficient of x squared there is what? It's 1. So this one, we simply need 2 brackets here. So you're going to have 2 brackets. Put x and x here. So what are we going to consider this time? Factors of what?
Of 2 plus 2.
But they must add up to? They must add
2,
up to
3,
negative.
negative.
So which factors are we talking about here? Factors of positive 2 that will add up to negative 3.
So meaning to say it's negative 2, negative 1 and negative 2.
So we must have negative 1 and what? Negative 2. If we multiply this, we get positive 2, which is fine. If we add this, we get negative 3. So these are the numbers that we want. Negative 1 and negative 1 and negative 2. That's it. What about x plus 2? Is there anything that we can do there?
No, everything is fine.
It's fine there. Even the 9, everything is fine. Over, we are back again. Factorization. This time, again, we've got coefficient of x squared, which is 1. So you just need 2 brackets there. X here, x here. So which factors are we considering? Factors of 1.
Negative 2 plus
which must add up to negative 2.
2 plus 1.
So we need factors of 1, but these factors of 1 must add up to negative 2. So which factors are we considering there?
Negative 1 and negative 1.
So it's gonna be negative 1 and negative 1. All right. If we multiply negative 1 times negative 1, it's a positive. If we add, we get a negative 2. So that's it. So we are going to have negative 1 here, negative 1 here. So at this stage, we are done. We've factorized everything and everything is under multiplication. Now we can cancel as long what we cancel is between the numerator and what? And the denominator. So what can we do? Which part can we cancel?
X negative 2 and x negative 2.
X negative 2, x negative 2, all right.
X negative 1 and x negative 1.
All right, we've got x negative 1 here, x negative 1, x negative 1 again. 2. All right, x plus 2, and x plus 2.
Yeah. No, we have to remain with x negative 1, 1.
All right, we saw that here. There. All right, you saw that
there.
Yeah,
there's a 2, yeah, there are 2, yeah.
We saw there's this one and this one.
This one in there. This one, yeah. And this one in that one, yeah.
All right, so at the end, we are remaining with what? 9 and what? And minus 3. So this is going to give us 9 over negative 3. And if you divide from your calculator, this will be what? A negative 3.
Yeah.
Is that 3, so?
Yeah.
So that is the whole idea of this part. This is the whole idea that you need to work with. So if you are to check, your factorization part is the one that is playing a major role. Your factorization part is the one that is playing a major role. If you are to check here now, this one, you need to properly factorize this this one that I'm having here on this part. There you need to know your factorization. It's not just a direct question that you can just answer to say, okay, I'm there. you need to know your factorization. So let us see this one. Still the same application, this one, saving something like 7 there. All right, so let's see. It's under division and multiplication. So as long as something is under division and multiplication, what we need is to interchange everything to be under multiplication. So we are supposed to focus with this part. So meaning to say, I'm just going to repeat everything as it is. We are not done. We haven't started factorization, so just rewrite as it is. So here we're just gonna rewrite everything as it is. All right, so this is over 3m minus 1 times 2m plus 3, 2m squared plus m minus 6. Then our division here now, we introduce what? Multiplication. The moment you introduce multiplication, what's happening? We are now interchanging. So we now have 3m squared plus 5m minus 2 over what? Over 4m plus 6. All right. From this stage, that is where now you are supposed to think of your factorization now to say, okay, I'm done with my multiplication. Everything is under multiplication. So we are supposed to factorize each and every part. Factorize. Okay, let's start with this part here. I'm just going to utilize this space for our factorization here. What can we do with this one? Let us just write it aside. We have got 4m. If you are to check here, if you are to analyze properly, it's from our grouping concept, whereby we know that if, let's say, here these two were the same, what were you going to do? You were going to simply factor out that common term. But if we check, these two are not common, these two. This is 2m minus 3. This is 3 minus 2m. So how can we make these two brackets to be the same? That is your question now. So we are going to have the first part here. We are going to have it as 4m squared into 2m minus 3, because already this one, it's carrying what? It's we are starting with m. And it's a positive, so there's nothing that we can do, just leave it like that. So your question is, how can we have this one now, 3 minus 2m as 2m minus as 2m minus 3? It must be a positive. So what are we supposed to do? We are supposed to factor out. All right. We are actually, yeah, that is the truth. We're supposed to rearrange, which is what is the same thing. If you rearrange, it was going to be minus 2m plus what?
2m plus 3.
Then what do you do from there? You factor out so that this becomes a positive. So you factor out negative. It's supposed to be a negative one, so that this becomes what? A positive, so that we get negative 2m divided to negative 1. It becomes positive 2m. Then you divide 3 divided to negative 1. It gives you negative 3. Now we have got the same bracket, but having or knowing that there is now a negative, this one, which is going to affect the sign that was here. What was the sign here? It was a plus.
Positive.
So a positive and a negative will give us what?
Yes.
So we are going to remain with negative 1 into 2m minus 3. So we have made these brackets to be the same. So once these brackets are the same, what are you going to do? Now you can factorize properly. So you factor this bracket out. So if we factor out this bracket, what is going to remain? If we factor out this bracket, we are going to remain with 4m squared minus what?
It's
minus
negative 1.
And what?
Yeah, that's the tricky part.
We see. So this one is now the same. And this one, what is it? This one. 4m squared minus 1.
Now it's a difference of 2 squares now.
We have a difference of 2 squares. So meaning to say, we shall have 2 brackets there, which is going to be what? 2m plus 1 into
minus 1. 2m minus 1. All right.
Yeah. How we seeing this one? So all
that's
this,
it.
everything that we read is just to confuse us. So meaning to say this part, the whole of it, we are now having these three brackets now.
All right. Yeah.
All right. So meaning to say we are going to have 2m minus 3. The order here does not matter whether you started with this one or the order does not matter. So just write all your brackets. 2m plus 1 into 2m minus 1.
Okay.
All right. Now we move on to this one. Is there anything that we can do?
Nothing you can do.
So there's nothing there. You're just going to write it is 3m minus 1. All right. Times. What about 2m plus 3? Is there anything that we can do? There's nothing also here. So you're just going to rewrite
there's nothing.
Everything over. We are now back to this one.
Okay,
so if you check here, it's different from those terms that we just write in two brackets because it's common. There we can, yes, we can do that, but we have to actually understand the concept behind on how to factorize that part. I think if we can have time, talk about that. But if you check here, we can simply say from our normal factorization by grouping, whenever the coefficient is not 1, we can multiply the first term to the last term first. So meaning to say, if we multiply 2m squared to negative 6, what we obtain? We're
obtaining negative
12m squared. So what you need now are the factors of negative 12m squared. But these factors of this term should add up to the middle term as it is, which is plus m or plus 1m. So do we have factors of negative 12? Factors of negative 12, that will give us a positive m.
So it should be negative 3 plus 4.
4. So you're going to have 4m and what? And negative 3m. All right. So these two terms now, we have to replace them into the middle term this time. So we are going to have this as 2m squared. We replace these terms into our middle term. So that will be what? Plus 4m, minus 3m. So we're going to have minus 3m minus 8. Once these terms, as you can see now, we are now having how many terms from what we had before? We are now having 1, 2, 3, 4 terms. So meaning to say, in order for us to factorize this, we are supposed to do it by what? By grouping now. This is where this type of equation was taken, where you are going to end up with something of this nature. It was actually taken from grouping, but here they give you a certain stage that you must know before. So you see this idea now where how they can give us this. Okay, what is common between the two terms here?
2m, yeah.
2m. So you can divide 2m squared divided to 2m. We remain with what? M. All right, 4m divided to 2m. 4 and 2. We remain with 2. All right. So here, what is common? So that the brackets, remember the idea here was that these two brackets were supposed to be common. That is the whole issue that we're trying to solve there. So meaning to say, on your factorization here, you are supposed to make sure that the bracket that you get is the same as this one. So what are we supposed to factor out so that we maintain the same bracket of m plus 2?
You factor out negative 3?
Negative 3, exactly. So negative 3m to negative 3 becomes a positive. Negative 6 to negative 3 becomes a positive. So once at this stage here that we are having here is the same as this stage that we had here. So that's where we go back now to factoring what is common. What is common here is m plus 2. And if we factor out m plus 2 here, we remain with what? 2m. Here we remain with what? With negative 3. So this is the same as this part. But here it was that after obtaining the two brackets, we saw that there was another factorization that had to take place again. But here, there's nothing that we can do. We are done. So these are the two brackets that we are going to obtain from this one, which is m plus 2 into what? into 2m minus 3.
2m.
Right.
3.
Times, as we can see here, we are having same scenario again. So sometimes they might just give us questions just to give us a lot of calculations, as we can see on this question. This one is the same scenario again, just like the previous part, because here we are not having what? We are not having a 1 there, so we can use the longer way. So if we multiply first term to the last term, what do we get? First term to the last term?
-6.
So you're going to have negative 6m squared. What are the factors of negative 6 that we add to obtain 5?
Negative 3, 3 and 2. 3 and negative 2.
All right. If we say 3 and negative 2, if we multiply, yes, you get negative 6. But if you add, are you going to get a 5? No, we are not going to obtain 5. So let's look for other factors. Which other factors can we think of?
If I say 3 and negative 2, you see.
So here we are supposed to use what? 6 and negative 1.
Oh, and negative 1, yeah.
So if we multiply this, we get negative 6. If we add, we get a 5.
Yeah.
So these are the ones that we are going to use. But knowing that there's m there, so it's going to be 3m squared plus what? Plus 6m minus 1m. So this will be minus m there, minus 2. So with the two factors that we have replaced them into the middle term, what are we seeing now? We can see that we now have 4 terms, and I said whenever you have got 4 terms, what you need is to group them into 2. So what is common for the first 2 terms here?
It's 3m.
3m. So if we factor out 3m, 3 and this one cancels, we remain with m. 6m divided to 3m, we're gonna remain with what? 2. That's so?
2.
So we must have the same bracket here from minus m minus 2. So as you can see from minus m minus 2, what we simply need to factor out is what? Negative 1. And so that this becomes a positive. So we now have a positive there. So that means we can factor out the common bracket. If these 2 brackets are not the same, redo it, because you must have a common bracket that you factor out now, which is m plus 2. By factoring out this, remaining with what? With the 3m here, remaining with minus 1. So meaning to say we are done. Is there anything that we can do further? There's nothing. So
and there's nothing in there.
This whole part that we were factorizing, we are going to remain with the m plus 2 into 3m minus 1. All right. Now we've got over this one. I think we can just factorize direct, and it's a linear expression there. What is common between these two? What is common between 2m? Here we do not have just 2 there exactly. So you're gonna factor out 2 there. So if you factor out 2, what do you remain with? 4m divided to 2, it's gonna give us what? 2m.
2m.
All right, then this one, 6 and 2.
It means 3 plus 3.
Positive 3. All right, so from this stage now, it's up to you now. This is the cancelling part that you are supposed to cancel, as long it is common from the numerator to the denominator. That's where we have to cancel. All right, so let's, which part can we cancel then?
You see 3m minus 1 and 3m minus 1.
We have 3m minus 1, okay. 3m minus 1, 3m minus 1, okay.
We've got 2m negative 3, yeah.
2m negative
2m
3.
minus 3.
Yeah. All right, 2m minus 3, okay.
We've got 2m plus 3.
2m plus 3, okay. This one and this one, okay.
We've got m plus 2.
Yes, m plus 2, yes.
I'm sure that's it. Yeah.
All right, so that's it, and we can't, there's nothing left. So here we are just taking what is left from the numerator is these 2 brackets. So we are going to have 2m plus 1 into 2m minus 1 over what? Here we are left with what? There's a 2 that is left in the denominator there. All right, so that's it. We are done. So this is what we can have at the end. All we need is to make sure that all the given expressions are being factorized where it is possible for you to factorize. Where it is possible for you to factorize, you have to make sure that everything is being factorized. All right, there's this one which had a quadratic part that right, let's just see the others. You just try them and see. So let me check which is it that I want us to see here. Then I want you to try the other one. All right, so it's this one. Then you try this one. I think it's a little bit direct. I want you to try this one because here we just have a concept of difference of two squares, and this one from our N2 again, it's this one I think can be done, so you can just work it out. I want us to discuss this one together here. Can we just try to discuss this one as we finish up? Simplify the following again. So what can we do here? There's a division here, so let's see. There's a division here, and also I've got a division there. All right. So as we said, whenever you see a question that has got division, multiplication, the first thing, just check to change everything to be under what? To be under multiplication before you think of factorizing. So we have to change this one. So you're gonna have m squared plus m minus 2 over 3m squared minus 2 minus 1. All right, if we multiply, we interchange the second one, the second fraction. So that means we have 9m squared plus what? 6m plus 1. Is that so? 2m squared plus m minus 6. All right, what about this one? What are we going to have? Minus 12 over 3m plus 1. All right, so this is what we are going to obtain from what? From our introduction of multiplication, where there's a division there. All right, so the major part that I want you to see is on the factorization, especially because this one we talked about it. We talked about this one. So let us just quickly try to see what's going to happen. All right, the first one I think is direct. Here, what do we need there? The factors of what? Because here it's a 1, so we need factors of -2 that will add up to give us +1 on m there. So do we have factors of -2 that will add up to +1? Factors of -2.
-2 and -1.
Negative what? -1 and 2.
Yeah.
So you're gonna have 2 and negative. All right, so 2 and -1. If you multiply this, we get -2. If we add, we get a +1. So it's +2 and -1, or -1 and +2, which is fine. All right, so if we check this one, we are back to that one that we had. The coefficient here is no longer a 1. So what are we going to need there? We are going back to our basics. 3m squared minus 2m minus 1. So you're going to multiply this. What do we get? First term and last term?
-3.
-3m squared. So what are the factors that we need from -3m squared? But if we add them, they must give us -2m. From this one, it must be -3 and what? And 1. And if we multiply this, we get -3. -3 plus 1, what do we get? We get a -2 here. So these are the ones that we are going to consider, but using what? Using m. So this will be -3m plus 1, which is 1m. So this will be just m like this, -1. All right, grouping into 2. What is common for the first 2 terms?
3m.
So we've got 3m squared and 3m. We've got m minus 3m, and this one we've got what? -1. Is that so? So what can we factor out on the second one so that we remain with the same bracket of m minus 1? Already we are having m minus 1. So what are you going to factor out? A plus so that
1.
it does not affect anything. A plus does not affect whatever that you have. All right, so the two brackets here are the same. So we are just going to factor out the common bracket m minus 1. Here we remain with what? 3m. Here we remain with a plus 1. And so this is what we're going to have. Two brackets, m minus 1 and the 3m plus 1. All right, so these are the two brackets that we're going to have. All right, so let's check the other part, which is the major part that I wanted us to check here. It follows that on this part, if you are to check here, yes, you can even use that same concept to say you multiply 9m squared plus 6m plus 1 like this. Okay, let's just do the longer way, then I will explain the shorter part. If you are to multiply this, what are you going to get if you multiply this first term and last term? You get 9m squared. So what you are going to see is that you need factors of 9m squared, but these factors must add up to 1. Must add up to positive 6m there. Are we seeing that they must add up to the 6m? So which factors of 9 that must add up to 6? Which numbers are we considering for 9?
3 by 3.
Are we seeing 3m and what? And 3m, isn't it? So if we are to take this now, we are going to have 9m squared. We replace this into the middle term. So it's going to be plus 3m plus 3m plus 1. All right. We group them into 2. What is common for the first two brackets?
3m.
3m. We divide 9m squared to 3m. It's going to be 3m, 3m and 3m, which is a plus 1. Already, this is what we have here, 3m plus 1. So what are we going to factor out so that it will be the same? We factor out a plus. So that we remain with what? With the 3m plus 1. So this bracket and this bracket are the same. So we are going to factor out 3m plus 1. What do we remain with from this one? We remain with 3m. Here we remain with what? With plus 1. So meaning to say this is what we're going to obtain here. 3m plus 1 into 3m plus 1. So this part, because of our time, I'm going to properly explain it in our another class. What I want you to know is that whenever you are given this type of an expression, it's referred to as a perfect square expression, where the first term it's a perfect square, and the last term it's a perfect square. Whenever you see this type of a person, the first term it's a perfect square, the last term it's a perfect square. You use this concept that a plus b squared is equal to a squared plus 2ab in our expansion plus b squared, or a minus b squared is equal to a squared minus 2ab plus b squared. So what you need to check is it. Yes, I'm having the first term. If you check here, it's a squared. A squared means it's a perfect square. B squared, it's a perfect square. So whenever you see this scenario like this, you trace it back to this format to say you must have two terms here, which is A and B. And if you check A and B inside this bracket, where are they taken from? Where are we seeing this A and B? These are simply the first term, the number that is being raised to the power of 2, and the last term, the number that is being raised to the power of what?
Of 2.
To the power of 2. So that's your A and B. So if we check here, if we say this is our perfect square, which terms are being raised to the power of 2? We take this 9m squared plus 6m plus 1. This is same as what? If we write it as a squared like this, it's same as the what is the square root of 9? The square root of 9 is 3. So it's same as we've got 3m squared. That's a squared plus our 2ab, which is a combination that we are given as 6m plus this one as a perfect square can be written as 1 squared. 1 is same as 1 squared. So as you can see, this is our A, this is our B. If you are to multiply them, let's multiply them and see if we get this part, because we are saying, yes, we can, the middle part is obtained by what? By multiplying 2 and A and B. If we multiply 2 times, what are we saying is our A? Our A is 3M times our B. What is our B? Our B is 1.
So
if we multiply this, what do we get? We get 6M, which is this term in the middle term, this one. Are using this type of equation. So whenever you've got this type of equation, you just need to know, is it a plus or a minus? Once it's a plus, you are going to have A plus B squared, where this is your A and this is your B. So meaning to say this whole part, we are going to simply factorize to say our A, which is A plus B squared, and we are saying our A here is what? Is 3M. So we are going to have 3M plus B, our B, which is what? Our B, which is what? Everything is being what? Everything is being squared from this part. So we are moving from this side to the factorization. We are moving from here to here. The same way that we can move from expanding. If we are expanding brackets, that's where we end up with this. But now we are removing the, we are factorizing, that is, we are putting in brackets. So as you can see, this answer and this answer the same. And it was a long way that we applied. So this one, like I said, I'm just going to explain it separately, but that is what you need to understand, is that from our perfect squares type of expression, where the first term is a perfect square and the last term is a perfect square, that's where you apply this one. It's best for you to apply that. So that is, you have to analyze your okay, here it's a perfect square. This one is also a perfect square. So let me try to apply this.
Yeah.
All right. So let's see this one. The other one we are given 2M squared. But like I said, if you can factorize using that other way that we use, it's fine. This one is just an advantage, like to know advantage. You see, all right. So what can we do on this one? Back again, we multiply. This one is not, it's 2 is not a perfect square. 6 is not a perfect square. So we can't be thinking of this application here. We have to go back to our way that we use. So we're going to multiply first and last, we get what?
It's negative 12.
So what are the factors of negative 12M squared? But if we add, we must get a positive 1M. So we need a positive 1 there from 12. Factors of negative 12, but should go back to 1. I think we must be thinking of 4 and what? 4 and negative 3. 3,
yeah.
So if we multiply 4 and negative 3, that's negative 12. If we add 4 plus negative 3, that's a positive 1. So we are going to replace them into our middle term 1M. So this will be 4M, this will be 3M. So it's going to be plus 4M minus 3M minus 6. So group into 2. What is common for the first two terms?
2M.
So we've got 2M. We factor out. This will be M plus what? Plus 2.
Plus 2.
So then let's check the last one. What is common between these last two terms? So that the bracket will be the same. Negative 3, exactly. So negative, that will be positive M. Negative 6 and negative 3 will be what?
Plus 2.
Plus 2 there. All right, so the brackets are the same. So you have to factor out M plus 2. You remain with what here? You remain with 2M minus 3.
Negative 3.
All right, so these are the two brackets that we are going to have. M plus 2 into 2M minus what?
Minus 3.
2M minus 3. All right, that is the whole idea there. After, let's check the other part. What can we do on this one? Here we don't need any special factorization. Here we just factor out what is common there.
It's 12. It's 4, sorry.
It's 4, so we're going to factor out 4. We divide 4M and 4. What are we going to have?
That means it's M.
Okay, minus 12 and 4, which is negative 3. All right, what about 3M plus 1? There's nothing that we're going to do. So this one is going to remain as what? As 3M plus 1. Is that so? All right. So once you're done with this part of factorization, now we can cancel now back the idea numerator to the what? To the denominator. So what can we do? Which part that we can cancel?
Let's start with the m minus 1.
Okay, m minus 1, m minus 1.
M plus m, 3m plus 1. 3m plus 1.
3m plus 1, 3m plus 1.
And m plus 2. Yeah, m plus 2.
M plus 2, m plus 2.
Here 2m minus 3, nothing. So 3m plus 1.
Another 3m plus 1, 3m plus 1.
After this, there's nothing. Yeah.
So there's nothing left. So meaning to say from the numerator, we are left with this part alone. So this is going to give us 4 into m minus 3. What about in the denominator? We are left with what from the denominator? We are left with 2m. What? 2m minus what? Minus 3. So there we are going to have this as 2m minus 3. You can even have the bracket if you want, or you can just leave it like that. It's one and the same thing. So as you can see, the ball part here lies on your factorization. You need to work on the factorization part. Basically, that is what you need. Those questions from our N2 parts are supposed to be considered about the factorization concept. So like I was saying, this one, I want you to try it. I want you to work it out so that we'll see if there is any problem. We can check it separately. Just we'll send, but if you are to simplify it, you are supposed to obtain the final answer is just supposed to be 2p plus q. So I want you to try and see if you're going to remain with 2p plus q on your final answer. All right, so we'll see. The rest we'll see if there's any other part. Like I said, I'm gonna try by all means if I can just have a slot now so that I'll create some other questions that you can just work on so that we'll revise them.
Okay.
Okay, no problem. Let's meet tomorrow.
All right. Thank you.
Okay.